The graphs of sine and cosine can be made directly from the unit circle. Sine is always looking at the y-coordinate of the unit circle. This is y-coordinate 1 up here, and this is y-coordinate -1 down here. And what we're going to do is we're going to watch just the vertical distance of this point as this point moves, and it's going to draw out a sine graph. Know that the angle is going to change from telling you about how much you rotate to being just along a line, just a linear, drawn out x-axis of the actual angles. And it allows us to create some extremely important functions. So here we go. La 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 la, and boom. So going out to 360 degrees, and I want to make sure you see that we've got angle 0. Oh, it doesn't include it there, but angle 0 is y value 0. Angle 90 degrees is a y value of 1. This is angle 180 degrees, and it's back on the x-axis with a value of 0. And then do you remember that sine is negative when your angle goes from pi to 2 pi? So the graph of sine is negative as you go from pi to 2, sorry, I've used the radians again, from 180 to 360. We'll be doing radians really soon. So 180 to 360, it goes down to -1 at 270 and then back up to 0. So that is one cycle of a graph of sine. And now we're going to go over to the classwork, and let's draw one cycle of sine. Okay, I drew that and then it disappeared. I'm having a problem. Okay, now it's... I am so sick of technology and all the minor issues with it. There we go. Now it's doing what I wanted. Okay, so sine starts at the origin, goes up to a value of 1 when you're at 90 degrees, and all of you are drawing this out. So you've got, do you have the classwork?
No.
Do you have the packets?
I have the packets out now.
Okay. Okay. Make sure you draw this out.
Yeah.
At 270, you're down to -1. And then when you go back to 360, you are back at a value of 0. This, make sure that you draw an upside down seriable and then a right side up seriable. That is looking at the curvature. You have to show a curvature that looks like this. It's not drawn by straight lines, and it's also not this, which I've seen people draw it like that before. So when we look at the 0 to 180, you don't draw it this way, don't draw it this way. It's got to be a bowl of cereal being spilled, and then followed by a bowl of cereal not being spilled. Then for cosine, we are watching the x value instead of watching the y value of the unit circle. But this red horizontal distance is turning into a red vertical distance. And here we go. And I can leave these leave a link to these so you can play with them later and see the creation of sine and cosine. You want to remember that cosine starts at the top. It starts at 1. And have fun with Battle of the Bands. If I have a pen. Let's see, maybe this will work. Let's see. And just make sure you get those homeworks. Have fun. So with cosine, now I know why I saw 2 people for the first time. It starts at 1, and then it goes down to 0. Do you remember how cosine, the x-coordinate, as my angle turns, goes from 1 down to 0? And the curvature is important. This needs to look like half of a bowl, the right half of a spilling bowl of cereal. And then between 90 and 270, it needs to be a bowl of cereal that is not spilling. It reaches a low point of -1 at 180. And then you go back to, now it's the left half of the spilled bowl of cereal. And then I showed you yesterday how sine and cosine are really the same graph, but just shifted. But you've got to remember which one is which. So I'm going to just type this in real quick. To take a look at the difference. And I'm also going to take off the axis numbers because right now this is actually showing it in radians, so I don't want to get that confused. And this is the origin right here. So this red curve is sine, and it just keeps repeating its cycle over and over again. Cosine starts up here at 1 and then starts going through its cycle. Do you realize how important waves are to your life? Everything we do with technology is dealing with waves. Waves are much more profound in our lives now than before, back when your parents were kids. So I want to just take a moment to have you recognize this is stuff we use all the time. Waves are very, very, very valuable to understand. And we're right at the very beginning of understanding waves. So what we're going to do is we're just going to practice graphing them for right now. So we've got our basic sine and cosine graph. And everything along here is stuff I've actually already talked to you about. And I'm going to point out the answers to the classwork. And I just want to make sure that you are aware of certain things, okay? You might see these equations for sine and cosine ultimately written out in this manner. But I want to explain to you some things that have been done in textbooks to try and help you understand better. But I think in the long run, it creates some weird issues. Do you notice how This has x minus c. And then it's a plus d over here. When we have addition outside a function, you remember that it moves it up or down, right? Everyone's with me, right? If you add onto the function itself, it moves it up or down. And you remember that you get to move it in the direction it says. But when addition occurs inside the function directly to the input variable x, you have to perform the opposite operation, because you're starting with a parent graph where x has already done its process. And if you add something on after the function has been drawn out, then you're just going to do whatever that outside addition says. But when you see that x has a number added to it before you're even able to create the function, you want to maybe think of it as you have to go backward in time before the graph occurred. And so every time you're dealing with an operation with x, you have to perform the opposite operation on your x coordinates. But every time you see an addition or a multiplication outside the function, which is what a and d are. A and d are arithmetic taking place after a graph has been positioned. You do exactly what they say to the y values. Now, traditionally, they write x minus c and then plus d to emphasize doing the opposite sign when it comes to x. And you've seen that before, right? Okay, I'll just assume yes. Here's the thing. They don't write x minus c divided by b, even though when you see a multiplication by b, you're going to have to actually divide by it. The fact that they decided to make it official in textbooks to write x minus c, and that they didn't then choose to do divided by b, I think is confusing, and they'd be better off if they just left this as x plus c. It would be much easier to explain. So I want you to be aware that while this formula shows x minus c, to emphasize the opposite of addition, they don't show that you're doing the opposite of multiplication, and instead just add to your formula list of what to do. But the bottom line of everything on this document that I'm about to show you, the bottom line is, if the operation occurs outside the function, you are just going to do those exact operations to your y values. You deal with multiplication before you deal with addition. But if the operation is with the x, be it multiplication or addition, you actually have to do the opposite operation that you see written down to the x's on your parent graph. And always do the multiplication division first, and then do the addition subtraction after. And really listen to that, because that, if you can grab a hold of that basic thing, opposite operations with the x to the x's, same operation with the y's to the y's, that will make this a lot easier. So just to overemphasize, the operations inside the function we are dealing with B and C. For those, you're going to change the x coordinates using the opposite operation. So if you see a multiplication by B, you're going to take the parent function's x coordinates and divide them by B. If you see a division by B, then you're going to multiply your original x coordinates by B, just always opposite operation. If you see addition by C, you're going to subtract C. If you see subtraction by C, you're going to add C to the original x coordinates. And again, looking at this equation, B is showing multiplication, C is showing subtraction / addition. Then the other two that I highlighted in yellow, A and D, those are outside the function operations. They will change the y coordinates using the actual operations that they are. So if you see multiplication by A, you're going to multiply the original y coordinate by A. If you see division by A, you're going to divide by A. If you see addition, you add. If you see subtraction, you subtract. And along with this, I want to point out, if you multiply by a negative number, following these rules that I'm telling you right here, with if it says multiply, you're going to multiply. If it says divide, divide. But if it's inside, when you see multiplication, divide. If you see division, multiply. If you follow those rules, you're going to find that you don't need to memorize an extra rule for how do I deal with multiplication by a negative. It's valuable to be aware that it causes a reflection. So here we go. You are going to sketch one cycle of each parent function and the given function using degree measure. And you're going to include 5 points, and I'll make sure you're clear on which 5 points. And then the full graph. Okay, when it comes to the full graph, I realize I may need to be a little bit lenient on you on this one, because some of these get to being a little bit too much. I want to make sure that you understand that the one cycle isn't the whole thing, but that from that one cycle, you can just keep redrawing it. So I want you to know that when I say the full graph, you can draw it as quickly as you want, and it doesn't need to be perfect or neat. I just want to make sure that you have the idea that the one cycle isn't the whole thing. I don't want you having to spend too much time graphing, though. So here we go. Know that in the answers, I'm going to show I may show more than just those two. So what we're going to do is start off with the parent graph is sine. Sine starts at the origin, goes up to a value of 1, comes back to 180, goes down to -1, and then back to 0 at 360, and then it would just repeat itself. So I'm just going to lightly sketch that. The x is being multiplied by a 3. That means I'm going to take these x coordinates and I'm going to divide them by 3. And that is going to tell me when a cycle begins, peaks, comes back to the center, hits a low point, and then comes back to the center. Because these waves always have an issue of you need to know when they are at the center axis. So this is your center axis. Now, the official math name of that, it's really cool. It's called the sinusoidal axis. But it's the center. It's the midline. And your trig functions are going to pass through that midline at certain angles. And then they're going to go peak and valley. So going back to the fact that we need to divide those x coordinates by 3, let's start with 360. What is 360 divided by 3? 120? And 120 is about here. This entire thing is being squished in. I am going to be able to go through all of this, one wave pattern, from here to here. In the meantime, I am multiplying outside the trig function by a 2. That means the y coordinates, there you go, the y coordinates of 1, 0, and -1 are going to be multiplying by 2. And I can do this slowly or quickly. So I'm going to do it slowly for right now since it's the first time. I'm going to draw an intermediate graph. I'm going to first draw if I multiply the y values by 2. When I multiply 0 by 2, it's still 0. When I multiply 1 by 2 and -1 by 2, I can see the stretch. So this is an extra graph that I'm not asking you to graph, but I'm trying to guide you through this. This is y equals 2 times sine x. Then you can take this graph and divide all the x's by 3, and that is going to squish it in toward that y-axis. And what you can do is, if you know that this is where you finish your cycle, you can cut that in half and then cut each half in half. And it might be 90. We can take a look. We divided the 360 by 3 and we got 120. What's 270 divided by 3? 90. So this is definitely where that low point. At 270, it's supposed to hit its low point, but divide by 3, and its low point is going to happen at 90. And then what is 180 divided by 3? 60. And what is 90 divided by 3? 30. So as I go along, it's going to be midline, high point, midline, low point, midline. And now I'm going to plot those points. Midline at 30 degrees, the high point. At 60 degrees, I'm back to the midline. At 90 degrees, I'm down to the low point. And then at 120, I'm back to the midline. That's the graph of the given function. That is the graph of 2 sine 3x. And I realize that it's a lot of work to draw the full graph. I am okay if you just do a quick draw. So let me explain. You're only supposed to draw the one cycle of sine, the parent graph. Here's the parent graph, but I'm going to do it quickly. Isn't that a terrible graph? It's a terrible graph. I just want to make sure that you understand that we are only looking, when we do one cycle of the graph, that isn't the whole graph. That's the only reason I'm wanting you to draw the full graph. I don't want you to waste time trying to be perfect about it though. So what you can do is kind of set it up and go, and maybe be off a little bit, and that's okay. And then just draw really quickly that it goes, not perfect, doesn't need to be perfect. I just want you to identify that you understand what's going on. Then when you see the answers, I'm going to show you what it officially looks like from a computer. You aren't going to draw this. You're going to just do a scribble of it. But I want you to take a really good look at the full graphs. I want you to look at the blue parent graph here and see the stretching vertically by 2 to get to the green graph. And then it literally is compressing from both sides toward the y-axis, compressing it in toward the y-axis. Can you see that green taller graph being compressed in when you look at this? And you just don't see it as well when you're looking at just one cycle. As far as tests go, you're only going to sketch one cycle. Again, scribble your full graphs, but look at the answer. And it's just, I really don't want it to cost you too much time. Okay. Back to sine again. This time I have only addition subtraction. When I see x minus 45, I'm going to actually add 45 to all of my x's. When I see plus 1 outside the function, I'm going to do that operation to the y's. So again, with the x, it's the opposite operation that you see. You see subtraction, so you're going to add. When it's outside the function, you do the same operation that you see. I'm going to draw the parent graph. And these are the 5 points I'm referring to when I say show the 5 points that begin and end the quarter cycles. And then we've got first quarter cycle, second quarter cycle, third quarter cycle, and fourth quarter cycle. And so I'm going to take each of the points and I'm going to move them right 45. And if you see that this is 90 right here, then that's halfway. Everything is moving right 45 and up 1. So if I take this point and move it right 45 and up 1, and then take this point and move it right 45 and up 1, and keep going. This point, right 45, up 1, right 45, up 1, right 45, up 1. If I don't have any multiplication division, then the graph is going to just shift. Can you see how valuable the multiplication and division is for when we're dealing with waves in real life? It's huge. The shifting is just an issue of timing or location. But the multiplication division is what really affects different waves. So there you go. Then drawing the full graphs, just real quick. Not a good graph. In fact, terrible, terrible graph. That was way too, it should actually be more like that. So again, I don't want you wasting time trying to draw the perfect graph. If you want to slow down and make it look pretty, you can, but please, you've got other things to do with your time. Because technology will graph these for us. The purpose of what we are learning is not your ability to graph, it's your ability to understand how the numbers and the graphs relate to each other. And then this one was like, yeah. There you go, good enough. But let me show you the answers because that's really, really valuable to look at. Here are the full graphs. And what I did was I showed the green one wasn't asked for you to draw, but it's me showing you one thing at a time. You can see from the blue sine graph shifting up 1 to the green graph and then shifting right 45 to take it to the red graph. And now we have cosine. For cosine, it starts at its peak, goes to the midline, the bottom, the midline, the top. And it's got to be curved so that it's a spilt bowl, a bowl holding cereal, a bowl spilling cereal. I'm multiplying outside the function by -5. That means I can literally take all of the y values that I see and multiply them by 5 or by -5. And let me show you how that automatically does two things at once if you just follow this basic rule. And I'm going to use green for intermediate because I'm just going to draw -5 cosine x. +1 multiplied by -5. 0 multiplied by -5. -1 multiplied by -5. 0 multiplied by negative 5, and 1 multiplied by negative 5. And that automatically stretches it by 5, but also flips it upside down. That reflection over the y-axis. And you're not going to draw perfect waves. Then I have x is being divided by 2. So what do I want to do to the x's if I see that x is divided by 2? I want to multiply my x's by 2. And my x coordinates are 0, 90, 180, 270, 360. Each of those is going to be multiplied by 2. So I'm starting with, oh, is there a hand? I heard something online. I think I see a hand. Did you have a question? Or is that an accidental hand? Okay, I'm going to go with accidental hand. Have all of you done that in a class at some point? Okay, my x value is 0. 0 times 2 is still 0. So that point is actually going to stay right where it's at. But then I go to 90. 90 multiplied by 2 takes me to 180. So where I'm supposed to be at the midline at 90 degrees, I'm now at the midline at 180 degrees. And my first quarter cycle is now being horizontally stretched out. My high point of 5 was happening at 180. If I multiply 180 by 2, that gives me 360. So my high point is now occurring at 360. And then I've got my second quarter cycle. 270 times 2. And perhaps you just see the pattern. At 540, I'm going to be back at my midline like I was at 270. And then double 360, that takes me to 720. 360 was where I was at my lowest point. So now 720 is where I'm at my lowest point, and I finish the cycle. And then with the full graph, again, you can just do a real quick rendition of that. And I want to show you what it looks like. And that's what it looks like if you look at the full graphs. The parent one is just the blue cosine one, but I do have it where it's showing you a middle graph. You don't have to draw that middle graph, just to help you see kind of the slow progress of getting to that red graph. Isn't that pretty though, looking at it? We should study sine waves and cosine waves more than we do. It's such a huge part of our lives now. And understanding what is going on with our technology means let's first understand waves. Or maybe not first, but that's one thing that needs to be understood. So that is the end of this classwork. I'm going to stop the recording.